let's talk quickly about the agenda of the demo. So first, we will show acquiring image on the edge. Then we'll push the data to the data lake. We will do some computation on the core with the image, including on the GPU. We will do some collaborative, some example of collaborative leveling, launching Coco annotator services. This is just an example of the service that we can manage in a secured manner. We will show our interfaces with the Python world, with the Jupyter notebook, and collaborative editing of notebooks, for instance, and also the interface to the scheduler. So the Python user can actually submit submit the workflow directly from the Python world, and will go to execute on the HPC cluster through the Activation services. And we'll show the an original AutoML solution, which is actually based on a workflow itself. It's a very open solution, and we will execute it on the core, on HPC cluster, for instance, or on cluster on demand. And this solution could be easily, I guess, integrated with HPU solution from Cray, the hyperparameter optimization that you develop within Cray and HPE. So we'll show the capacity to use any kind of visual environment to do AI, like TensorBoard, Wisdom, for instance. And finally, we'll show how we can manage to push back a model to the edge with a model as a service feature. And we'll show data deviation detection, which is a very important aspect for MLOps, being capable to manage and monitor the performances and the preciseness of model at execution. And we'll show also how to do audit, traceability, and ring trading of the model.
So as Denis said, I'll start by showing how we manage the whole pipeline of the step one. So let's start to log in our infrastructure platform that we have prepared for the demo today. So as you see here, this is the web portal of the blockchain solution. It provides 4 kind of portals. Each portals is adapted and built for several kind of users, as they did say before. So I will start by using the automation dashboard, the first one. And during the demo, I will see the others portals too. So let's start by this first one. Log in. Okay.
Yeah.
So let's go to workflow automation portal. So for the demo today, we prepared this end-to-end use case using, as Denis said, using machine learning, deep learning, image acquisition to illustrate end-to-end pipeline from the image acquisition until a model deployment. So as you see in my right side here, we provide a set of catalogs, workflow catalogs, sorry, that is adapted and built for each domain. So we have some examples of fluid dynamics on HPC, for example, using Paraview and other examples you can see here. We have some workflows for example, machine learning. Those workflows are some pre-built examples to be used by data scientists to quickly see how they can build themselves their own workflow. So as you can see, we have a lot of data analytics, text analysis, log analysis.
if we open a workflow, you can see the graph of the workflow.
Okay.
We will show you that actually during the course of the execution.
Okay.
One thing that's important to understand is that we provide a set of building blocks. We provide ready-to-use workflows, but this is something that is completely customizable by the end customer. Is putting here its own automation workflow for its own automation platform and for its own HPC or AI usage. So for instance, here we have AI. Andrew, can you show the HPC fluid dynamic workflow with labs and with ParaView interfaces to parallel visualization system. So workflows are made of tasks. The task can be in any language, and it can also be executed natively, executed in the cloud, or executed in containers.
So let's start by some the workflows we have built for the step 1 of this presentation. So this workflow, this one, it will be responsible to go to an edge device, as we can see here. Edge 1, Edge 2, it's a pre-built infrastructure for this demo, but you can have the number of edge devices you want. So, for example, let's select the first edge device. Okay, yeah. So let's, for example, fetch 35 images from the edge 1, for example. And the search time, let's keep it by default. So we'll search 35 images of ants, for example, coming from the edge 1. So let's.
So of course, here we are executing manually the workflow, but in many systems, this is triggered automatically by the API to go and execute something on the edge or on a specific node. Go ahead, Andrew.
Okay. So now I will launch the same workflow, but using a different edge device, for example, the edge 2, with the same number of images and different keyword, like this, for example. Let's submit it. And now you can see in our resource manager web portal the whole infrastructure used for this demo. And here we can see the edge, the edge device that is are used by the workflow we submitted before. We can monitor the edge device, for example, seeing how many the memory consumption, CPU usage of this node, this one. Sorry. Yes, for example, if you want to see the usage of the edge device, of the CPU usage, the memory, so you can monitor and see the hardware consumption statistics using the resource management. Denis, you want to add something?
No, just for the sake of the demo, we have put together this small platform. So we have an elastic node source that we will fire on AWS in a moment. This is some of the things we do with Legal and General, for instance, but on Azure. So we have the default node source, which on my slides is called the core. We have an edge node source which represent different edge resources, and finally at the bottom we have a GPU node source.
So let's go back to the workflow automation, sorry. And here you can see the jobs that we have submitted to the edge device. And clicking to the result list, for example, you can see some image that was carried by the edge 1. And the edge 2, just close this one. So yes, you can click here and you can see the ants that was given by the edge 2, for example. So this is a simple illustration for this demo today. So let's start by doing the next step. So now I will illustrate, the step 2. The step 2 consists of doing some data pre-processing on the image that was available into the data lake. So as you see before, the first workflow got some image from the edge device and put it into the data lake, and now we will process those images using, for example, an image classification workflow. So let's go back to the workflow automation. And now, as you can see here, we have a small train image classification workflow that uses a convolutional neural network that will use the data set built from the images acquired by the edge device. And let's start it using just 2 epochs to be very fast. It's just an illustration because if you want to get a better result, you need to put more epochs if you need. So if you want to select the results to be used by this workflow, you can select by using the node access token, for example. So let's train this image classification deep neural network on the GPU node. And let's, sorry?
Go ahead, Andrew. While you submit it, I wanted to say, so here we are using a variable from the job and the task. The variables are typed, and we use a variable to use the selection mechanism to execute on a node which has GPUs.
Yes. So if I go back to the resource manager, you can see in my left, the GPU node is correctly used by this workflow. So you can as we did before for the edge device, you can also monitor and see the statistic of the hardware consumption on this node.
So with respect to customer, we also have customer which reserve certain nodes for certain types of user. They can have nodes which are reserved by a project, by user. You can have node source which will fire expenses on the cloud only for a given project and with a maximum amount of money per month or per day or whatever. Go ahead, Andrew.
Okay, thank you. So now the flow is still done, okay. So if you want to see the workflow execution, we can go to the scheduling portal. And here we can see which step of the workflow is run. So we can see that the current workflow running on the GPU node is currently done. So it's finished now. And we can see the job output in my right side. And if I go back to the workflow automation, so yes, the job is done as we see in the scheduling portal. We can click in the result list and see the deep learning results, for example. So those are images used for training and prediction, for example, just to illustrate some image that was correctly classified by the workflow, but we can see also some image that were classified wrongly. So yeah. Do you have any questions until now at this stage? No?
Go ahead, Andrew.
Okay. So now I will show how to perform, for example, some image labelization in a collaborative manner using the Cocoa annotator. So let's go back to the automation and let's go to the cloud automation. And now, as you can see here, we have a pre-built service that is named Cocoa annotator. This service is very useful when we want to perform some image labelization. So it's a open source free and open source tool, web-based tool, multi-user, and with authentication and the support to HTTPS and the more. So we not only support co-connotator, we also support any kind of data labeling tool. If you want to integrate, it's very easy to add more services here. So as we see, the service was deployed correctly. And if I click into the open endpoint, you can see that I am logging. So you can see the int versus b data set and some labels that we have added manually to these data sets. So the user is free to label the images he wants and work collaboratively on the same data set if needed. Any questions? No? Okay, so let's go back to the automation dashboard. Let's close this cells, and I'll show you the next step. So the next step is the step number 4 that enable the user to perform some collaborative work using Jupyter Lab, for example. So if I come back to the service workflows, we can type here Jupyter, for example, and we can also deploy a Jupyter Lab instance in our infrastructure. So let's put a sample token for active. Let's execute the service. So the service is running, and it will be available in a few seconds. So the service was deployed successfully, as you can see here. And now let's start to go through the Jupyter Lab endpoint. Let's put the token. And now you are logged into your own Jupyter Lab environment. This Jupyter Lab service can be deployed in the node source you want. So it can be deployed on a GPU instance or Elastic Cloud instance. So you can select which kind of node source you want to deploy this service. And the proactive service used in this demo provide, for example, some workflows, or some notebooks, Jupyter notebooks with some examples. And one thing I'd like to talk also about is about the Jupyter kernel. The Jupyter kernel, proactive Jupyter kernel, sorry, it's a kernel developed by Activium that help the user to build, construct a job workflow using some macros inside the code. So those macros help to construct a workflow in the backend, and I'll show you how it works. So let's put the connection URL first. So as you see, we'll be connecting into the scheduler. Okay, it's done. You can also visualize the proactive web portals inside your own Jupyter environment. As you can see here, I just add my credentials. Okay, I will hide this tab, and now you can see the workflow automation portals showed before. So here you can see some the jobs that are currently executing. And now let's create a small example of a proactive workflow. So first I will create a task named T1 that consists of a sample of hello world, a task T2 that it's a bash task instead of a Python task. By default, the task is a Python task. And, and let's create a task 3 that depends of T1 and T2. Okay, it's done. So if you want to see and visualize our job, our workflow before submitting it, you can use the macro named draw job. And you can see the T1, T2, and T3 tasks. And if you want to submit, there is a sample macro named submit job. And you can see the job execution. So it's 195, and it will be showing the column. So yes, it's currently running. It was successfully submitted, and it will finish in a few seconds because it's a very simple job. And that it's composed with a sample print hello world. Yes, so it's done. As you can see, the default job it's done. And if you want to got the result of this workflow inside the Jupyter notebook, you can also do it by using the printing job output, as you can see here. So the idea of the proactive Jupyter kernel is to help data scientists to perform some experiments inside our own Jupyter environment, and just switching by, for example, from Python to proactive and using the proper macros, the user is able to submit this workflow or this notebook computation to the infrastructure very easily.
So basically, the people who like to work in Python can use seamlessly all HPC and AI cluster or even the edge directly from Python. In the example that Andrew showed, we started as a service, the Jupyter Lab, but this can also be started on the desktop directly of the data engineer, which can then work on his own machine and then seamlessly submit the task to the HPC AI cluster.
So, as you know, Jupyter environment also have a lot of plugins, and you can also use, for example, Git plugins to compare your current working version of the notebook to the master branch of the Git repository, for example. Talk a little about the proactive Python SDK. You can also use and submit proactive jobs using our Python SDK. So it's like the proactive Jupyter kernel, but more for developers. So you have two choices, or you can use Jupyter kernel, or you can use our Python SDK. But you don't only provide the SDK on Python, you can also find the SDK on MATLAB and R and other languages also. So let's close the Jupyter. And now you just close the current running Jupyter Lab instance. Okay, it's done. And now I will go to the step number 5. And for this step, before starting with 5.1, I will start with 5.3 because this one usually requires more time consuming. And the next I will perform the 5.2 and at the end the 5.1. So I will go in a backward way to be more efficient. So let's start with automate on the cluster, elastic cluster, sorry. So let's go back to the workflow automation. Now I will switch to the workflow, AutoML optimization. And as you can see here, we provide AutoML mechanism. As Denise explained before, it's a AutoML mechanism implemented in a workflow manner. So let's start by submit it into Elastic Cloud for a brief demo. So let's select Elastic Cloud. And here you can select how many parallel executions per iteration you want to do. So let's fix to 50, sorry, and 2 iterations max. So at the end, we will have 100 optimization tasks to be done until the end of the workflow. And for this workflow, we'll use Visdoom as for visualization, for example. I let the default parameters, I just switch the algorithm to random because to be more fast and efficient for this demo, but you can select the algorithm you want. So let's start this workflow.
So those tuning parameters, this is something you can change. So if you have some specific version of
yes,
tuning.
exactly. So yes, I forgot to say that you can select the workflow you want to optimize. This workflow can be a set of tasks, like a workflow, like a pipeline, but it can be also a script. So you should have a Python script that have some machine learning or deep learning code or a mathematical function implemented on Python or any other language. You can specify it here and define the search space, defining the variables you want to perform your optimization. So let's start by submitting this workflow. If I don't forget anything, I think it's okay. Okay, submit. It will take a few seconds. Sometimes you have, okay, it's done. And now you'll be seeing the workflow here into the current jobs. It will take a few seconds. Okay, it's done. And if you want to see the whole workflow execution, let's go to the scheduling portal. And here you can see which step of the AutoML optimization is done. And as you see, the AutoML optimization workflow is very complex. It starts by deploying some recurrent services for data storage, for visualization, like Visdoom or TensorBoard if you want. And during the whole pipeline, you see which algorithm it will be using and the strategy to split and perform the optimization in a parallel manner. So it's a AutoML mechanism implemented as a workflow. So it's much more simple to understand and to customize than a single black box task, for example, as we can see in some implementations in the web. So
again, this is a very open solution for doing AutoML. And while many AutoML are specific to a library, here you can do AutoML with any kind of framework, and it's very easy for end user to extend it with new tuning strategy, for instance. Go ahead, Andrew. I think we should start seeing the resource appearing on the resource manager. Yes.
Yes. So as you can see here, there is a lot of nodes that are deployed in a deployed manner. So it started to deploy some nodes in the Cloud Elastic resource.
So this is so we are firing the VM right now. So they are deploying. So we monitor that, of course, and when they will be up and running, we'll be able to execute computation in the VM. But this is actually what Legal and General is doing with us, with our software on Azure.
Just to explain a bit about the automated workflow. Oh, sorry. Let's open it on the studio. Oops.
So I think this is the first time Andrews will show the studio, right, in the demo.
Yes. So as you can see here, the studio provides a graphical interface that we can customize and visualize and adapt and modify our workflow to be executed. So this is how the automated workflow was built.
Maybe show the task menu to show the set of specific tasks that we have. So move it around, put it at the bottom. So the solution you see is completely flexible and open to the user. You see the palette of various templates, and actually our end customer customize this to put the specific building block such that non-expert data scientists, like citizen data scientists, can build some chain themselves without programming skill. And we have various configuration with various building blocks. We have setting for big data, setting for deep learning, setting for machine learning, etc. And this is actually what you see. To tell you everything is the bucket that we saw previously in the different workflow automation. Those are the buckets which are provided by the system and extensible by the user.
So let's start to the next step. So I just close this one. And now I will show how we can do some computation in a PBS cluster for Slurm, as I said. So we have, as Denise showed before, in our resource manager, we have a small node source here, named meta-scheduling Slurm PBS LSF. And now let's start by doing some computation with it. So I will go to the automation dashboard, and I'll select basic example, this one, and by starting submit it to this specific node source. As you can see, I use the name, the same name of the node source here. So now, as you can see, the meta-scheduling Slurm was started by deploying one node for computation. And yes, it is using as we expected. It is using by the previous job.
So just a precision, when we act as a meta scheduler, we are taking on demand the node onto the cluster, which is a good solution that allows our customer to have an HPC cluster to maintain the traditional users which like to do command line interface with LSF or Slurm, most likely, and also to bring on the cluster the new users which are doing big data, HPC, AI together, and can still continue to have a portal and workflows of Python interface to execute to the cluster. So with the Python interface that we shown, this meta scheduling aspect, user can seamlessly submit a job to a Slurm cluster. And other can use the portal. Go ahead, Andrews.
Okay. So now let's start to the point, to the number 5.1. So the 5.1 is the same of 5.3, but we will launch the AutoML on the CPU or GPU node. So let's go back to the workflow automation. I close the other tabs. Okay. And now let's go to AutoML optimization. And let's start by doing some computation on the host on the core with a smaller iteration, and by activating TensorBoard instead of Wisdom, for example. Arrays with random and arrays with the same function to optimize. So if I don't forget anything, everything is well. So let's submit it. Okay, it's done.
So maybe show quickly the resource manager. I think we can move to the last step of the demo.
Yes. Yes.
So here we are executing on the core resources of the platform.
So let's start the step number 7 that consists of publishing machine learning model to be used via a REST API. So we will deploy a machine learning model as a service in this stage. So for this example, I'll switch to the model as a service. And in this catalog, you can see some pre-built tasks that enable you to easily deploy a machine learning model using productive tasks. So let's start by launching the deploy flower classification model. It's a sample workflow that train and deploy machine learning model using the Iris dataset. So let's start by submitting it. Okay, it's done. And now let's wait a few seconds before we can access the service. You can see that there is a lot of jobs currently running in parallel. We have the previews, AutoML, propagation. Our model service deployment is currently pending. The model as a service work, in fact, it's a choice, but in this case, it's a Docker container that runs a Python service exposing a REST API. And inside this container, we have the model that's usually a binary file that's stored inside the container. And when you deploy a new model, it keeps the history of the models inside the container itself. But if you want to deploy different models in parallel, you can do also. But if you want to use the same model service instance to deploy a second version of the model, you can do also. And you can also select which version you want to use of the model itself. So the prediction, because in fact each call into the prediction API, the service itself, it loads the model, do some prediction, and free the model. But it's an architecture choice. You can also put the model in memory if you want. But usually, if you want to have, in fact, if you want to switch, to have the capability to switch between different versions of the models, you should, for each prediction, load the model into the container, do the prediction, free the model. So if you, when you deploy a new version, it will load the new version.
So we will show now step 7, which is the model deployment and data deviation detection and traceability. Go ahead, Andrews. Okay,
so let's start by enabling the deviation detection mechanism inside a previous deployed model as a service. So let's keep all parameters in true. So let's execute it. Okay. And it will take a few seconds to update the model parameter. Okay, it's almost done, yeah. And now let's start by submit a prediction into this model that launch drift alert control. So let's switch to the model as a service catalog. And now for the prediction example, I start by showing the prediction mechanism. Delete. And now I'll switch to a data that contains some drift inside. So let's start by launching this workflow. Okay. And now, if everything is fine, you will see a small notification in my left side here. So the workflow is still running. It's currently okay. So it is doing the prediction. And now our web notification service was sent. We'll be receiving it in a few seconds. Okay, it's
here
done.
it is.
And let's click on it. So here you can see the notification mechanisms that is launched when a data drift is detected inside the prediction API. So let's mark it as red. And to finish, we can also access the model service endpoint and see the parameters of the deployed service, as well as the logs. And we can see here the data drift alert and why it was called, because the threshold was set to 1.9 and the score was 14. So it was it sends a web notification when it happens. And if you want to see the predictions or visualize the predictions, you can click here and we can visualize the prediction data that was sent to the prediction API endpoint. So you can see manually we have see, in fact, we have used a data Iris data set with data drift inside it. So we can check and see where is the data drift. So I think it's okay.
So I think we covered everything from core to cloud and back to core.